Ketan sir? Yeah. Okay. Good afternoon, sir. So, how's the winter? Not audible.
Yeah, it's good. Heavy winters this time.
Enable YouTube link, sir, then we'll start.
Yeah, we are on live.
Okay. So, welcome all of you, all the students and the source person on our fifth day of our workshop, that is on virtual lab. And today, resource persons from IIT, Mr. Amit Sharma. So, I'm handing over the session to Mr. Amit Sharma.
Oh, thank you, ma'am. Thank you so much.
He'll explain few experiments related to the first year labs. And now I'm handing over the session, sir.
Okay, thank you, ma'am. Thank you so much. So, welcome all of you guys. This is the fifth day of the virtual lab workshop at Dayanand Sagar University, and we are going to demonstrate some of the experiments from digital electronics lab and some are from the basic electronics lab from IIT Kharagpur, and also some of the experiments from just give me a second, some of the experiments from physics also. Just give me a second, guys. I'll share my screen.
Amit sir, your voice is not audible. Hello? Hello?
Hello.
Yeah, it's fine. Hello?
Yeah. Uh, Now audible now?
Yeah, it's audible now.
Okay. So welcome, guys. This is the fifth day of the virtual labs workshop at Dayanand Sagar University, and today we are going to give you the demonstration of some of the experiments from electronics engineering and some of the from chemical engineering also. As this is the fifth day, I'm going to give you the. This session is divided into two parts. The first one is I'll give you the brief introduction about the virtual labs. What is virtual lab? What are the advantages of the virtual lab? What is the process to use the different experiments on the virtual labs and other things. And in the second part, I will give you the demonstration on different experiments of your field. So the today's objective of the workshop is to give you the understanding about the working of the experiments available on the virtual lab platform, and also the development of the virtual lab experiments. So the agenda of today's workshop is to give you the objective of the online labs, then the silent features of the online labs, then we discuss about the physical labs versus online labs, that is the differentiation between the physical labs and the online labs, or we can say that the advantages of the online labs over physical laboratories. Then the demonstration of online experiments. Then the demonstration on online experimentation. Then what is the virtual lab? So basically the virtual lab is a project initiated by Ministry of Education, previously Ministry of Human Resources and Development, Government of India, under the mission NMEICT, National Mission on Education through Information and Communication Technology. ICT means with the help of internet, we are going to use these experiments available on the online platform, and with the help of your mobile phone, with the help of your computers, you can use these experiments 24/7 and work on these experiments in the similar way as you work in your physical laboratories. So in this virtual lab platform, we design the environment similar to our physical laboratories. Like you have your lab manuals when you go to your physical laboratory. In that lab manual, you have aim, you have theory, the procedures, the results, the tables, and other things. Similarly, here we have the theory section, the procedures, some quizzes are also available, and also the web tutorials also available, the video lectures and animated demonstration and self-evaluation for questions is also available on our virtual lab platform. So when we move to this virtual lab platform, I'll show you each and everything. Then what is the motivation behind the virtual lab? Like what we are doing, we limit the physical distance by performing the experiment. So like in this current situation, we have the study, most of the institutes have this education in the online process, online mode. And while we are in the online mode, we are not able to access our physical laboratories at our institutes. So in this time, what we have the best option available, the virtual labs. So at least not going, as you know, you are not going to your physical laboratories, you have a second way to perform the experiments and try and increase your concepts about that particular topic or about that particular experiment. Then the proliferation of quality labs, like each and every lab available is going under the quality analysis process thousands of the time, and on the basis of the feedbacks provided by the users regularly. Like if we just create any of the new lab, we provide that lab with the quality analysis process. Like we check the bugs in that experiment, what are the requirements of the experiment, is we have to add something in that experiment, or we have to make changes in that experiment, the theory content available in the experiment is okay or need to be correct. Each and everything is maintained at that process, and the result is that when the lab present in the when we present the lab to the user, that will be a quality labs. So each and every part of quality analysis will done by the help of the expertise of that field, like from the professors of IITs and some of the experts of that field also. And we are sharing the costly equipment with the help of this project also. Then the objective of the virtual lab is, as I discussed earlier, that to provide the remote access to the labs in various disciplines of the engineering science, and to also the students to learn at their own pace and their own curiosity, to increase the curiosity. Suppose for example, if a 12th class student just wants to check for the engineering science field what kind of the experiments are available, what kind of the topics he or she will going to learn in the future, so he can decide, he or she may decide that in which field the person wants to continue. So this is also used to increase the curiosity of the student or the person. Then we share the costly equipment and the resources available to each and every person available in our or to each and every user which who use the experiments. So according to our motto, that is the everyone must be on the same page, we deliver each and every project, we deliver each and every content to each and every student of IIT, to each and every student of any other institutes and from the private institutes also, and to the person who is just want to learn something. Like if someone from the electronics and communication engineering just want to perform the experiments for mechanical engineering, so the complete data is available to that person also. Or a person who is on the not in the education field, but he is just, but any of the person just wants to elaborate the information about any of the thing, so he or she may come here and elaborate that also. So according to this, we have our motto that everyone must be on the same page. So content available to one person is similar for each and every person. So the learning management system on our website, we have PDFs, ebooks, the video demonstration documents, like the e-contents. Each and every content is available with each and every tab of the experiment. So you just cross-check each and everything from that part also. Then we have the e-tutorials, like video contents available, the animations and the simulations are available. Then we have the web resources like Wikipedia links, like NPTEL link and other things. Then for the self-assessment, we provide some multiple choice questions at each stages of the experiments. Like just when you start the experiment, we have a pre-test. Some 5 to 10 questions are available for your pre-test, that for that from which you just check your knowledge about the particular experiment or give the answer and check the result at the same time. And then after performing the experiment, we have the post test. In that post test, some higher level questions are available of that experiment or with the topic, so you can check that also. Then we have the online feedback form available. If you find anything or you just want to share the feedback of that particular experiment, you want to share something, you just write the feedback to the makers of that particular experiments. So basically, this is the Sakshak portal. So what is the Sakshak portal? The Sakshak portal is the first website of Government of India of Ministry of Education. So anything available in the field of education is first reflect on that particular website, that is the Sakshat. If you search for the Sakshat on the Google, just write SAKSHAT Sakshat, and each and everything is available on your screen. Like we divide this uh, website into 4 different categories, like for the school students, like from nursery to 12th class, then the graduate undergraduate students, like for graduation, for post graduations, and for other different courses are also available in this particular environment. So you can check each and every part here. So anything came up in the field of education from class nursery to the higher level is reflect here. So you get the link for the virtual labs also from this website. You may get the link for the spoken tutorials also. You may get the link for the Diksha, the program which is recently initiated by the Ministry for the mathematics students of class 8th to 12th, I think. And we also have some NPTEL links also available. You can join the certified any of the certification program of your field or from another field from this website also. So basically, this is the uh, one umbrella from where you can access each and every part in the field of education. That is the Sakshat portal. So the main 3 tabs of our Sakshat portal is the NPTEL, from where we can just get the video and the theory content of our engineering science field, or you just go to the NPTEL program and join any of the certification program you want to join. Then we have the link for our spoken tutorials, like if you want to discuss your project with someone, or you just want to learn any of the language from the institutes or from the available courses, you can just do with the help of the spoken tutorial. And the last one is the virtual labs, from where you are able to do the lab experiments available. So in the virtual labs, the project was started back in 2009, and from 2009 to 2015 we developed approximately 150 different labs. But at that time we don't have any limitation about the development. At that time, we use the MATLAB. At that time, we use LabVIEW, the Flash players, the Quest 3D players, and the other paid softwares also. But nowadays, it is difficult for the user to use these softwares. Like the Flash player is discontinued by the Google, and the other LabVIEW is also a licensed program. So there must be a version of LabVIEW available at the user end. So that is why we discontinue all the things and try to develop new experiment in on the open source environment, so that you are able to use these experiments or the content without any requirement of any of supporting softwares. So we are in the migration period of converting the existing experiments from paid softwares to the open source environment softwares. So for that, we mostly converted the available experiments, but some of the experiments are still in the pipeline. So the silent features of our virtual labs are the anytime, anywhere labs. So you can access the virtual laboratory 24/7 from anywhere, from your college, from your hostel, from your home, while traveling. And anytime you want to perform the experiment, you just go to the virtual lab website and perform the experiments with the help of the internet. You can use the experiments on your mobile phone also. We have the facility of performing the experiments on mobile phone also available. Then we have a common web interface. So what is the common web interface means? So in the virtual lab project, we have 12 participating institutes. So some of the IITs, NITs, and some of the private institutes are available. So we develop each institute work in different field. So we combine each and every website of the different institutes, the participating institutes, and provide that link on the vlab.co.in. So from vlab.co.in, any of the person from electronics can access the lab of electronics engineering. The student from mechanical engineering can access the mechanical engineering labs. That is also from the vlab.co.in. So everything is available on a single platform, and for each and every engineering branch or available branches, the portal is vlab.co.in. Then the accessibility through internet connection in PC, laptop, or mobile phone, as I discussed earlier. Then the user-friendly web front-end and back-end simulation. So in our virtual laboratories, what we do, we use the GUI representation of our environment. Like we have our mouse and keyboard, and with the help of our mouse and keyboard, we have to give the input to our system, and on the basis of that input, we calculate our system automatically calculate and provide you the output in the visualization form or any of the form available for the required in the required format for the experiment. So here we don't need to learn any kind of coding that we have to create some environment to perform the experiment. Everything is available to you. Just go and perform the experiment with the help of the instructions. Then the high quality content. So the complete content which is developed available on the virtual lab platform is developed with the help of the expertise of that field, or with the help of the professors of IITs and institutions. So the content which is available is completely a high quality content. You can rely on that also. These are the basically silent features of our virtual labs. Then we have a differentiation between the physical laboratories and the virtual laboratories. So on the basis of cost, to exist a physical laboratory, it comes under the few lakhs or maybe in crores. So to give the existence of a physical laboratory is a is a task which requires some of the money and the maintenance also. While on the case of virtual labs, the cost is almost nil, because everyone nowadays has a PC or internet available, and the mobile phone also. So you can access the labs with the help of this internet, with the help of the internet and the mobile phones easily. Then the availability. In case of the physical laboratory, we have a limited time period to access the lab. So suppose you have your laboratory for a 2 hour period in a week, then you can only access the lab for 2 hours in a week. While in case of the virtual lab, you are able to access the lab 24/7 from anywhere, anytime. Then in the way on the basis of experimentation, in case of the innovation, the limited uh, options are available in case of the physical laboratories, while the virtual labs provide the better and safer options for innovation of the experiments. Like if you want to perform the experiment with wrong procedure, you can do that also, because there is no problem of harming of the equipment, that the equipment may not be damaged, because everything is on the virtual environment. just refresh and everything will be similar to the previous. Then we have a user experience. On the basis of user experience, the physical laboratory is the best way, while the second best option, if we don't we are not able to use the physical laboratories, is the virtual labs. So in the current scenario of the COVID-19 pandemic, we have the best option available for us is the virtual lab. It is completely free of cost. Nothing is involved financially, and you require just mobile phone and the internet connection to perform any of the experiment available on the portal. So basically, this is the list of our broad areas of virtual lab. So any of the student or person from physical science wants to perform the experiment, the chemical science, the mathematical, computer science, electrical, electronics. So mostly each and everything is covered. Each and every engineering science field is covered in this project or in this environment. So on the virtual lab platform right now, we have more than 280 different labs available with more than 1120 or approximately 1200 experiments. More than 1200 experiments are available on the virtual lab platform. So you have the very big data available to play with. So these are the list of our participating institutes like IIT Roorkee, IIT Delhi, IIT Bombay, IIT Guwahati, Triple IIT Hyderabad, IIT Kanpur, IIT Madras, Kharagpur, Amrita University, Dayal Bagh University, NIT Surathkal, and the CAE Pune. So these are the participating institute, and this is the backbone of our virtual lab project. Now, a main thing is come here that we have nodal centers. Like your institute is also a nodal center of our IIT Roorkee, and right now more than 300, 1,300 different institutes has a nodal center for the virtual labs, and also it is not possible to create or develop each and every experiment, each and every syllabus to cover each and every syllabus from the country. So that is why we introduce the process of development by the help of nodal centers. Suppose you point out any of the lab which is not available on the virtual lab platform, and in your curriculum, you can develop that lab and provide that lab to this particular environment for the use of the nation. So we now you are also the participating institute if you just create any of the laboratory and provide this laboratory to this website. So this is the pic of our simulation laboratory. Like this is from the civil engineering. These kind of the simulated environments are available on our experiments. Then this is the pic of a electrical engineering laboratory. The from DC machines, I think the experiment is available. These kind of the setup is available in the virtual laboratory. You have to make the connection and check the connection, and on the basis of your results, the graph is automatically created. So this is the impact of our project. Like currently we have more than 1,300 different nodal centers available across the India. Then approximately 2,300 workshops is run, and we have the participating institutes or about participating persons 7 lakh approximately, and the usage is of 45 lakh. So this is the overall statistics of our virtual laboratory. We monitor these things on the daily basis, and in this IIT Roorkee is on the top. The usage from the IIT Roorkee experiments is on the top, and from top 10 experiments which is most widely used on this particular website is from IIT Roorkee, from Digital Electronics Laboratory, and this is the analysis of the different labs developed by IIT Roorkee. So now this is all from the presentation side for virtual lab experimentations, and now the main part come up, that how to perform the experiments. So if you guys have any doubt, you just ask, or we will move to this part also. Okay. So for performing any of the experiment, we have our website, that is www.vlab.co.in. So once you write this website on any of the search engine like Chrome or the Firefox or Opera, any of uh, just write www.vlab.co.in. This front page will come up. Now the users, the intended users, the college students are our users, the high school students, the researchers, and the different engineering colleges students like you are our intended users who use these labs for regular basis. And also the faculty members of different institutes also use these labs for giving the demonstration of any different topics for making the education more easy. So now let's move to the demonstration part. So guys, if you have any query, you may just ask. So our main website is www.vlab.co.in. So this is our main website, and this website is divided into three different parts. The first one is the objectives and the philosophy of the experiments. Then we have the broad areas of virtual lab. So basically, this is the library of virtual lab. You want to choose any of the experiment, just go with the broad areas and perform the experiment. This is the list of the participating institutes. If you want to check the working of the different institutes, like in which field which institute works, just go to the participating institutes and check. Then we have a list link of our secondary portal, that is VLab Dev portal. So what is the working of this VLab Dev portal? So once we create any of the lab, we develop any of the lab, initially we place that lab into our secondary portal, that is the VLabs Dev lab. And in this, we make the quality analysis check, and once the quality analysis is done, the lab is approved, there will be no change, no changes in the lab. Then we transfer that lab or migrate that lab from the secondary portal to our main portal, that is vlab.co.in. So now let's move for the experiment, like electronics and communication engineering. From the, I'll click on the electronics and communication engineering laboratory, and in the field of electronics and communication, we have these of the labs available for working. Like just right click on the basic electronics lab. Okay, so we skip this lab for now as the server is not available for this laboratory, and we just check the lab of chemical science, and we have an inorganic chemistry laboratory available. And in this different laboratory, we have the experiments related to our chemistry. And the first experiment is water analysis determination of physical laboratory of physical parameters. Sorry. So initially we have objective, then we have theory. So in this particular experiment, what we are going to do is we calculate the turbidity with the help of these meters. So this is the complete theory, the pH, the turbidity, the pH, and the electrical conductivity. The three parts of this experiment is available. So this is the complete theory. If you are the user, you just wants to recap your knowledge about that experiment or about this topic, you just read out. Then we have a procedure available here. So this is the complete procedure to perform the experiment. Then we have a self-evaluation process. So for this, we have to make our login. So I'll have my login account. Just give me a second. For the new users, just click on the create an account and register yourself on this. So this is the self-evaluation question answers. Then we have a simulator. So once I click on the simulator, so this is the way. So this is the main part of our experimentation, like how to perform the experiment. So to perform the experiment, what is the procedure? Just go to www.vlab.co.in, then choose any of the broad experiment from the broad areas and move to the simulator part. So basically, this is the experiment. Initially, in this experiment, what we are going to do, we have three tests here: the pH reading of the water, then the turbidity, and the electrical conductivity. These three tests are available on this particular experiment. So the first is the pH reading of the water. So if you are the user, you don't know about this particular experiment, we have a instruction tab available here. Just click on this particular instruction and read out these instructions and perform the experiment with the help of these instructions. So we have this setup available. We have the pH meter and we have the solution available here. So first, what we have to do, we have to standardize our pH meter on the basis of our buffer solution for 4 pH and for 7 pH. I choose the 4 pH solution and click on the standardize button. Once I click on the standardize button, our pH meter is standardized at 4 pH. Then for the buffer solution 2, that is for the 7 pH, and click on the standardize button. Once I click on the standardize button, the pH meter is standardized at 7 pH, and the select this tab for select water sample is now active. So for sample, what we have the tap water, we have the well water, distilled water, sea water, and from these we have to check. So I'll click on the well water and click on the switch on button. So as I click on the switch on button, it shows the pH of the meter. The pH of that particular well water is 7.8. Now I click on the check for the distilled water and click on the switch on button. The distilled water pH is 5.8. Now I click on the sea water and click on the switch on button. It shows that the 8.3 pH. Now check for the second test, the turbidity. So for the turbidity, we have the nephelometer available in our laboratory, and similar meter is available here. And what we have to do, if we don't know the procedure, what we just click on the instruction button and check for the experimentation. Then what we have to do, we have our formazine suspension available of 20 NTU. We have to standardize our meter with the help of this suspension and click on the standardize button. Once I click on the standardize button, it will take the sample and place into the meter and standardize my device with the help of this 20 NTU solution. Now, once I standardize my device, the select water sample button is enabled. Now we have two available waters, like drinking water and the sea water. I'll check for the sea water initially and click on the load sample. Once I click on the load sample, the sample will load to my device and show me the turbidity of 8 NTU. Now I'll check the turbidity of my drinking water and click on the load sample. The same process will repeat and it calculate the turbidity of my drinking water, and it is 2. So for the turbidity test, what we have, the turbidity of our drinking water is 2. Then the turbidity of sea water is 8, and the turbidity of our suspension is 20. Now we'll move to our third test, that is the electrical conductivity. So for the electrical conductivity, to check the electrical conductivity, we have the conductivity meter. The same process we have to repeat. In this, for standardization of our meter, what we have the KCl solution, which is of 1412 microsiemens per centimeter, and click on the standardize button. Once I click on the standardize button, my meter will standardize at 1412 microsiemens per centimeter, and then we have the samples. So in this we have totally pure water, the typical DI water, distilled water, RO water, tap water, potable water, then sea water. So I'll check for the sea water and click on the switch on button. Once I click on the switch on button, it shows the electrical conductivity that it is 56,000 microsiemens per centimeter. Now I'll check for the tap water. and click on switch on. So for the tap water, the electrical conductivity is 537. Now for the RO water, click on the switch on button and it shows that 93. Now totally pure water, click on the switch on button and it is 0.055 microsiemens per centimeter. So these are the three different tests on the basis of our first experiment for water analysis for physical content. Now I'll check that the electronics, yeah, this lab is now available. Now we will check some of the experiment from this lab. So this is the basic electronics laboratory and click on the list of experiments. So in this particular laboratory, we have 17 different experiments. Like initially we have the familiarization with resistor, the familiarization with capacitor, then the inductor, then Ohm's law, and for the diodes, then experiments on diode and rectifiers and BJT and common for BJT and the black box also. So now I hope that you get the idea how to perform the experiment and expect from the students of the DSU that they give some of the answers from the questions available in this particular experiment. So I'll click on the familiarization with resistor. Will take some time. So this is the experiment. What we have initially, we have the theory. Then this is the complete theory for the resistors. The type of resistors are, the two type of resistors are available, the fixed resistor and the variable resistor. Then the reading value of the resistors. So we have 4-band code available and the 5-band code available. So in the 4-band code, the first two digits are for the numbers. Then we have the multiplier available with us. Then we have the band for our tolerance. In the similar case, for the 5-band code, we have 3 digits, then multiplier, and then the tolerance. So these are the kind of resistors available. So this is the color coding for our resistance. So this is the way to read the values. I hope that you go to this and we have these codes. So for learning the codes, color code, what we have, the BB Roy of Great Britain had a very good wife. So these are the color coding. Like for black is for 0, brown is for 1, red is for 2, then orange is for 3, yellow is for 4, and so on. And for the tolerance, what we have, the gold is for 5, the silver is for 10, and none is for 20. And then we have the multiplier on the similar basis. The multiplication of black is 10 is to the power 0, that is 1. For brown, that is 10 is to the power 1, that is 10, and tolerance also. So this is the carbon film resistor. Then we have the metal film resistors, CFR and MFR. These are the things, and wire wound resistors. So now let's move to our quiz. So this is our quiz. So what we have initially, we have the table of color code for resistor. So this is the color code. Now we have our first question. Enter the resistance value. So anyone from the session can decode this. Are you able to do this? First one is the yellow, that is 4. Then for violet, that is 7. Guys?
Sir.
Yeah. Any? What is the answer for the first one? Enter the resistance value.
4 3
4, 3. Okay.
3. Sorry.
Just try to do. Like yellow is for 4.
4
7.
7
Violet
3.
is for 7. And what is the multiplier here? 10 raised to power 3.
2 power 3.
Yes.
Yes.
So I'll write 47 and then we have to choose the unit. The 4 10 is to the power 3 is for kilo ohms, that is 1000. Okay, then enter the tolerance. So what is the tolerance here, guys?
5, sir.
5. Okay, then click on the check button. So it shows that the resistance value is correct, the unit value is correct, and the tolerance value is also correct. Now give the answer for second, the 2. What will be the code? Green is for calculate, guys. Give me the answer.
5 2.
5 2. Then what is the multiplier?
10 power minus 1.
10 is to the power minus 1.
Ten power 0.
So I'll write 52. Then what is the correct value? What's the tolerance?
10, sir.
Here, it shows that the incorrect resistance value, the correct unit, and the correct tolerance. So our
5.2, sir. 5.2.
okay, the 5.2 is the answer. Okay, so this is correct. So then third, fourth, and fifth, try at your own. If anyone wants to try here, you can open your mobile phone and perform this experiment. So do this on your own basis. Now let's move to our second experiment. So I have these labs are. Do you think that these labs are interesting for you?
Yes, sir.
Yes, sir.
These are useful labs or not? Have you done any of the lab before on virtual labs?
Yes, sir.
Sir.
Okay. So it's taking so much of time. So the list of experiment. Now we'll choose the second experiment like Ohm's law. I'll click on the Ohm's law. Just a second, wait for a minute. This will load. Okay. So similarly, we use the same format as the previous one and try to copy the physical laboratories lab manual. Like initially what we have the objectives of this experiment, then we have the theory. So this is the complete theory of this particular experiment. So this is the complete theory for this experiment. So anyone tell me what is the Ohm's law, guys? What is Ohm's law?
V equal to IR.
Okay, V is equals to IR is the formula. What is the law?
Potential difference across two ends of a conductor is directly proportional to the current flowing through it for a constant temperature.
Okay. Yeah, good. So this is the experiment here. I'll click on this procedure part. So this is the complete procedure to perform the experiment. So in this particular experiment, what we have this kind of the setup of our Ohm's law. Like we have the ammeter, we have the voltmeter available, the resistance, and the battery source, the power source. So what we have to do, we have to take the different readings and calculate the value of our current in the particular resistance on a particular voltages and draw the graph at the last. So this is the complete procedure to perform the experiment. Then we have our second experiment, like what is the changes in the result when we use more than one resistance of same value or different value. Then in the case of the parallel, then for the non-ohmic devices. So I'll click on the simulator. So in this particular experiment, we have 7 ways to perform the experiment. In the first part, we have the Ohm's law. We have a circuit available, and we have to take the readings with the help of our procedure. Then, if you want to just create your own circuit, like to have to draw the circuit of Ohm's law, and after that you are able to take the readings. Then the Ohm's law for the resistance in series, similarly for the draw circuit as well, then for the resistance in parallel and for the draw circuit also, and in the last the non-ohmic devices. So initially I'll click on the second one, Ohm's law, the draw circuit. Just wait, it takes some time. Okay, meanwhile the simulator will open. Just give me the answer of these questions if you are able to. Let's check. So what is the value of resistor in the ohm? Okay, the circuit is not, the picture is not coming right now. So okay, what is the seventh one? So resistance and current are inversely proportional, directly proportional, not related, similar to voltage. So what is the answer, guys, for the seventh question?
Inversely
Yeah?
proportional.
Inversely proportional.
Okay. So inversely proportional. So, okay, are you able to do the sixth one? If the voltage in the given circuit was cut in half, so what would be the current value? Guys? Anyone?
Thirty milliamperes.
30 milliamperes. Okay. Any other? Okay. So what is the power in the given circuit?
35 watts.
35 watts.
35 watts. So if the voltage across a fixed value of resistance is increased 5 times, what does the current do? Fourth.
It increases by a factor of 5.
It increases by a factor of 5. Any other, guys? Any
No,
other?
sir, it decreases by a factor of 5.
It decreases by a factor of 5.
Yes, sir, decreases.
Okay, it decreases by a factor of 5. If doubling the voltage across a resistor doubles the current through the resistor, then anyone, guys? Any answer for the third question?
Resistor will don't change.
Resistor value did not change. The B. Any other?
Yeah.
Same, sir.
Pardon? Okay. So this is the numerical, and this is also the numerical. Who wants to try? So first one, what is the value of the resistor in ohms? Are you, anyone?
It's a 2.7 kilo.
2.7 kilo ohm. Any other answer? Okay, try for the second question also. Any answer, guys, for the second question?
So 333.3.
Okay. Then click on submit button. So the first is okay, the second is also okay, the third is okay, the fourth is not okay. Okay, I think the D. The sixth is also not okay.
60.
60. Okay. Okay. So these are the right answers. So okay. So this is the quiz for this particular Ohm's law. Now we will check our Ohm's law experiment. So basically in this particular experiment, what we have the voltmeter available with us. Then we have the ammeter also available. Then we have the resistance, the battery, and the ground button. So I'll make a connection just with the help of my drag and drop option to connect the points. I'll make a connection. Just give me the answer that the connection is correct or not. So I'll make this. Is this correct? Is the connections are correct? Anyone guys? So okay, for the users who do not know about the experiment or just not have the complete knowledge about this particular experiment, we have an instruction button also available. You can check the instructions and perform the experiment with the help of the instructions. So my question is, I'll make the connections. These are the connections in your on your screen. So are the connections are correct or not?
So the voltmeter should be directly connected to ammeter.
Okay, the voltmeter should be directly connected to the ammeter. Okay, I'll click on the check button. So it shows that the connections are wrong. So in this particular experiment, what we have to make a correct connections. Okay, so I'll reset my connections. And click on the check button. Now it shows that the right connections set the resistance and input DC voltage. Okay. So now, what is the procedure to perform the experiment? What we have to make the changes, we have to fix a resistance value, and then we have to change the different DC voltages, and on the different DC voltages, we have to calculate the value of our current, and on the basis of the values of current and voltages, I have to create my graph. So I'll set the value of my resistance to 1 and now change the value of my voltage. So initially I'll choose the 5. So what is the answer? I'll click on the add to table button. Once I click on the add to table button, when the voltage is 5, the current is 5. Now I'll choose the value of my voltage to 10 and click on add to table. On the voltage of 10, the current is 10 milliampere. Then I'll change the value to 15 and click on the add to table. Then 20, click on add to table. And click on the plot button. Once I click on the plot button, it shows me the graph. Okay guys, so this is the way to perform the experiment. It is the easiest way to perform any of the experiment available on the virtual laboratory. So it just take 2 to 3 minutes to perform this experiment and to understand the concept. So it is a time saving concept also. If you are just going to work on the particular experiment or any of the experiment in your physical laboratory, once you move check these experiment on the virtual laboratory, so it become easier to perform the experiment on the in the physical laboratory by performing these experiment on the virtual labs. So this is the experiment on Ohm's law. So now let me check the experiment for the half wave rectification. We have this is the second experiment. Meanwhile, we check the another experiment on digital electronics lab. Like I'll click on the virtual lab platform, then the electronics and communication, and then we have the digital electronics laboratory. So in this digital electronics laboratory, we have a list of experiment. So in this list of experiment, the verification and interpretation of truth table for AND, OR, NOT, NAND, NOR, XOR, XNOR gates is available. And this is the part of your basic electronics subject. You are, I think each and every person is know about the gates. There is a theory part. So this is the complete theory of our gates. So for the AND gate, this is my logic symbol. This is my truth table. This is my RTL logic, AND gate through RTL logic. So each and everything is available on this platform. You have to just check and read out the instructions carefully and perform the experiments. Then we have a pre-test available here. So this is the pre-test for this particular experiment. So give me the answer, guys. Electronic circuits that operates on one or more input signal to produce a standard output. What is the answer?
Logic gates.
Logic gates. Okay. Second, a gate gives the output as 1 only if all the input signals are 1.
AND gate.
AND gate. The Boolean expression of an OR gate is
A plus B.
A plus B. The gate which is used to reverse the output obtained is
Not.
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 so which of the following gate will return a 1 only if both the inputs are 0?
Exclusive OR.
Exclusive OR. Any other answer? Okay. So NAND is the answer. NAND is the answer. Okay. So this is the pre-test. Then we have the procedure to perform the experiment. So in this particular experiment, we designed these gates with two simulators. The two different simulators are available. In the first simulator, the actual presentation of our physical laboratory kit is available. And in the second simulator, what we have a logic circuit diagram. We have to give the input as well as the output and check our truth table. I'll show you. Click on the simulator and AND gate. So these are the simulator 1 and simulator 2. So in the second simulator, we have to verify our truth table of AND gate. So in this, we have to provide the input with the help of our keyboard, and we have to give the output as well. So for the input of 1 and 1, what will be the output? 1. I'll write 0 here and click on check button. So it shows me that the combination of the input and output is incorrect. So this is for the self-evaluation or self-learning process or for the revision of the gates. So the correct answer is 1. Now for 1 and 0.
0.
For 0 and 1.
0.
0 and 0.
Also 0.
0.
The truth table. Then we will move to our first simulator. So this is our main simulator and it is similar to our physical laboratory. So in this, similarly, we have the instruction button. If you don't know about the working of about the procedure of this particular experiment, just click on the instruction and read the instruction and perform the experiment. So what we have to do, the first step is just to connect the battery. Once you connect the battery, click on the switch on button. When you click on the switch on button, it shows you the flow of the charge from the circuit, and we have a switch A input and switch B input. And with the help of NPN transistor, we observe our output with the help of this LED. So I'll click on 1 and 1. Once I click on the 1 and 1 button, the output is true. The LED will glow. For the input of 1 and 0, the output is 0. For the input of 1 and 0, the output is 0. And for the input of 0 and 0, the output is 0. So this is the experiment on the basis of our AND gate. Similarly, you can check any of the experiment like XOR gate. So this is the XOR gate experiment. Just follow the instruction and perform the experiment. You have two simulators similarly available. So I'll show these labs from your first year first year syllabus, and also in these virtual lab platform, you have higher laboratories also available, like uh, digital signal processing lab, the signal and system lab, so analog signal networking and measurement lab. So from here, in the measurement, you are able to perform the experiment on the basis of KVL and KCLs and the theorems, Norton theorems also. And similarly, if you move to our electrical engineering department or the computer science department, the subjects like problem solving lab, the software engineering lab, data structure lab, computer programming lab, the Python programming lab, HTML, each and every image processing lab. So these are the subjects from your higher semesters. So you are able to do these experiments also from here. So I'll explain the things here. So this is our half wave rectification experiment. So I'll give the demonstration on this also. So this is the complete theory of the half wave rectification. Then we have the procedure available. Then we have our oscilloscope tutorial. So what is the oscilloscope? I think you know that. Then we have the simulator, the half wave simulator, the half wave rectifier. So it takes some time. Just wait for this. Meanwhile, we check the different experiments from this also. This is the 12, these are the 12 different experiments available, like on the half adder and full adder. You are going to study these things in your digital electronics subject in third semester if you are from the computer science or electronics background. The half wave rectifier, full wave rectifier, or half wave subtractor, full subtractor, then the flip flops and the multiplexer, demultiplexer, the code converters. So each and everything is available here. So this is our half wave rectification experiment. So in this, we have our oscilloscope screen. This is our oscilloscope screen. This is our controller, and these are for the frequency, and this is the answers. So we have the instruction available here. Set the value of RL. So if you want to set any of the value like 500, then click on switch on button, provide the sine wave, and click on the oscilloscope button. Once you click on the oscilloscope button, each and everything is active now. You are able to change the frequency. So this is the channel 1 input. So in oscilloscope, we have two channels, one for the input part and second channel for the output. Then we have the ground. So these are the controllers. Like if you want to change the value of your voltage divisions, for the voltage divisions, like I set the division here for 5. The 5 means this box is of 5 volt and my amplitude of my signal is 1 hertz. So I'll change the value up to 2 and up to -2 here. You are also able to change the frequency and set the value of frequency also. So this is the division. Let's set to 1. This is for shift your Y position. This is to shift to your Y position. This is for your second channel. So this is the output of your half wave rectification. This is for your second channel. You can change the value of your voltage differences. You check the able to check the value of your ground. Then we have a dual function available here. So this is the dual function. So you can check the value of input as well as the output here. And now you just calculate your ripple factor or VRMS with the help of your calculator available here. And the peak current is this. So this is the experiment on the basis of half wave rectification. So each and every experiment available is very easy and easy to understand, easy to perform. You just go to the particular lab, perform the experiment. So to perform any of the experiment, what we have vlab.co.in our website. Just go to this website and perform any of the experiment. Now guys, if you have any doubt, just please ask. This is all from the presentation side and for the demonstration side also. If any of the doubt you have, just ask or write in the chat box. We will try to resolve that. And if you don't have any doubt, we just end up this session. I hope that these labs are useful for you and you are going to use these lab in your future. If anyone wants to share anything,
So any doubt, student? Any query? Doubt?
guys, if you wants to share something, please, or any doubt, or
Any,
if you want.
uh,
So okay, this is
you
all
want to
from
say something?
our side, ma'am.
Okay,
So
sir.
over to
Just
you.
1
Over to
minute.
you. Yeah, sure.
Yes, sir. Just 1 minute, sir. I'll share feedback link. Students, I'm writing feedback link in chat box. Please fill.
And also one important thing that this session is also available on YouTube and previous sessions also available on YouTube. If you guys have any problem or you want to check any of the lab, different lab and more resources are also available on our YouTube channel. I'll share the link of our YouTube channel. You can check that also. And just go to that channel and please like, share and subscribe our YouTube channel. And other courses are
YouTube.
also available.
Yes, yes. So all the lectures are recorded on YouTube. So I should already share a link with you if you want to cross check once again. Like if you have any doubts, just go and cross check once again the YouTube link and all. Okay. And I just now I've shared a feedback link. Just fill that form. Once you fill the form, automatically the certificate will generate and it will go to your mail ID. So please write correct email IDs and correct name. Okay. Only one time like limit is.
Doubt.
Yes, tell me.
Ma'am, based on today's class, I don't think we'll be able to form any reflection notes, like particularly like note-wise.
Note-wise means?
Like how we had the first session, ma'am, where the ma'am took class, we have notes based on that, so we can refer
Okay.
to it and write. But based on today's class, we had many experiments and stuff. So how do you want
No
us to write the
problem.
reflection notes?
No problem. I have shared. No morning. I have shared. What do you have to write in reflection note? You
That's
didn't
the
get
only
mail.
thing which we have to write.
You didn't get mail.
No, ma'am, I got that's the only thing. So nothing which we had to write from this PPT which was done today.
No. Nothing. Whatever the questions I asked, I have already
Okay,
mailed
ma'am.
you people. Same thing you just write. Okay.
Yeah.
Ma'am, should we describe the experiment and write the procedure, anything?
Nothing, nothing, nothing. 1 second, 1 second. I'll just wait. I'll open the one. Just wait.
Ma'am, so nothing about the experiments, just the general questions which you asked.
Wait. No, it depends upon you, how you want to represent your reflection note. If you want to give example, if you want to give an example like this is that, for example, the reflection note should contain what all you have learned in this virtual lab session.
Ma'am, better to share your screen. I'll give you the confirmation. Just.
Okay, sir. Okay, fine. I'm the presenter. Sir?
Yes, ma'am. Now you are the presenter, ma'am.
Okay, fine. Email we can't open. Is it possible? Can you open?
Just click on share the entire screen.
Okay. Then
Yeah.
it's visible. Reflection note content.
It's blackboard.
Shared.
Your screen is shared, ma'am.
Screen share. Sir, reflection note content दिखाई दे रहा है आपको?
Screen is visible, but there is a like word content only. Blank word file only.
1 second, blank. Okay.
Just open the feedback form and
I'll copy this content what we have to write in.
okay.
Now it's visible? I think yes.
Yes, ma'am. Reflection notes should contain that things.
Yes.
It's visible.
Contain. So what all you have learned in this virtual lab session? First, you have to just put the heading and you write. Then your reflection on our virtual lab session. How this session help you and what did you gain from this course? Then in that you have to, if you want, you can give example of any lab. Correct? No? What gain you got from this course, or you can say through this virtual lab workshop. Third one, how you will able to use this experience in future. So you just write how you can use this virtual lab platform in future also. For example, many labs are there. Correct? In future you have a analog electronics lab, maybe related to the computer science. Lot of labs are there. So just check all these labs on virtual lab. Write about that. For example, gain you can mention any simple example, any simple experiment you just write in gain. You are asking, no, shall I write about the experiment or not? You people are asking, no. So sir I think sir gave 4 5 example. Any one example you take and just write your experience based on that. Anything else?
Ma'am, what is the word limit?
No word limit. 2 3 pages fine. 3 pages fine.
Okay, ma'am. Should it be in handwritten format?
It's your wish. If you want to write by hand, it's your wish. Just scan it and upload.
Okay, ma'am.
Okay. So it's not a common like fixed pattern. You follow this and that. I just gave simple 3 points to you people. Now it's your idea how you are representing your reflection note by using this virtual live experience. So in future, how it's useful for you. What is a major gain you got right now? And all these things you just write in your language, in your words, you just write. 2 3 pages is sufficient.
Reflection notes should be mailed to your email ID, ma'am? Should we mail it, ma'am?
Not me, class teacher. Just mail all this to your class teacher. Later, we will take either from the class teacher, we'll just ask the Google Classroom link from the class teacher, or if required, we will tell the directly we'll take from the class teacher. Don't worry about that. You just send all the reflection note to the class teacher.
Okay.
Because it's one lab, no? Anything else? Chetan sir?
Yes, ma'am.
Chetan sir?
Yes, ma'am.
I think done, sir.
Yeah,
Thank
done,
you so
ma'am.
much, sir.
Thank you, ma'am.
Okay, sir. Okay, sir. Bye, sir.
Bye, ma'am.
Thank you, student. Thank you. Bye.
Thank you, ma'am.
Thank you, ma'am.
Just fill the form. It is active only for 30 minutes.
Yeah, ma'am.